Okay, so I think I am live. I'm gonna check. I was like, I don't trust software. Like you can say I'm live, but am I live? Am I really? Um, let's see. Yeah, so I'm showing live. Cool. So we are this morning going to be focusing on kind of coding data structures and conditional statements and kind of some runtime stuff, just to kind of get you oriented in the right place and understanding what we mean by when we say all these terms and words, and then what do they mean for you as you're trying to code through stuff. So to start off with, we're going to be talking about Python data structures. And when I say Python data structures, what I mean is when you code, right, the information while you're manipulating it has to go somewhere and be saved somewhere in order for you to continue to do that manipulation. Think of it as like the short-term memory of your brain. Like your mom tells you to do a list of 5 things, right? You store it in your short-term memory, and then it's pushed to your long-term memory whenever it's pushed to your long-term memory. In our case, long-term memory is going to be like cloud environments, data centers, excuse me, databases, things like that, which anyone can pull from that knowledge bank to get information. But in your code, right, you're going to have to kind of store that information so you can use it later. And there are a few methods of being able to store information in Python. The most common one you're going to have is what's called a list. You're going to have, after list, the most common is going to be dictionaries, and that's you short word dict. They no more than 3 characters for each one. You're going to have tuples. I guess that's the exception. And then you're going to have sets. We're not going to go over tuples or tuples. I think in this class, I don't really think they come up much in general coding interviews at this level, but we will focus on list, dict, and set because those are way more common and way more used to solve actual problems. Tuples are basically lists, they just can't be changed. And so it's not really a large lift in understanding how to use it. But again, I've not really seen them be a part of like interview question answers. And so I'm not going to focus on that. We're going to start off our day with learning about list. Well, actually, data structures in general. So you have, and actually we're going to put strings here because strings are a form of a data structure. You can go back and forth between strings and lists. So we're going to put strings. All right. And that's actually str. So you have these 5 kind of data structures. They all have their own conditions, rules, and formats. The key thing to remember is you can kind of go back and forth between these formats. And certain formats are beneficial for certain instances. And really what you want to do is build up your memory of when to use certain structures for their benefits. And that will get you through the coding interview. Never think that you have to stick to one. I often find switching between, I think a lot of them, list to string and back works perfectly fine. Maybe not the best way, I think, anymore, but there are definitely different ways for you to attach this. So the first thing you're going to have to remember is list. So let's talk about it. Let's say you have a list. And what is a list? It's basically formatted like this. And we can have, I like pepperoni. I always do sorry, I have a mouth pizza addiction. We're going to have sausage. We're going to have cheese. And we're going to have sauce. And we're going to have some onions. I think that's enough for my point. Okay. And we're going to call this pizza. So remember, variables, which we'll keep expanding on what variables can do. Variables are like a small plastic storage container that has information. So it's kind of where you store it with like the label. So pizza will be the label on the storage box. And then the list can store multiple items in it. The thing is, they have to be stored in a certain order, kind of like in a line. If you've ever been in like a queue and you have your little ticket, and like your ticket is ticket number 26, and the person behind you is 27, the person in front of you is 25. That's how lists work. They are ordered. So, and unfortunately, they're not ordered from one. So they start at zero. So this would be zero. This would be one. This would be two, three, and four, right? So, um, and so that no, that doesn't cause any coding issues. So this bracket represents a list. So just remember that. So I could have made an empty list. I'm going to show you how to make an empty list and called it pizza, and it would have been just like that. I added elements. Things inside of a list are called elements. There are 1, 2, 3, 4, 5 elements from positions 0 through 4, right? So I don't have to actually count because this is a computer code. And so I like not having to actually think. And to be honest, they get so big sometimes. Like, how are you going to count them? Like, you could have a table with like 1,000 different columns, and your list for one thing might be all that. So you can find the length by using len, and it will give you the length of your list. Now, as you saw yesterday, when we were using like names, and we got all of the names from um, our spaceship, we can actually call by positions as well. Let me actually rerun that code. For argument's sake, it's going to still be messed up where it's messed up. Okay, that's fine. So from yesterday, we still have this name list. Okay, just like we have. Now, just like this is labeled 0, so if I were to do pizza, and I'm going to call the first element of pizza, I'm going to open my brackets, and I'm going to put a 0. That's calling the first element of pizza. Hold on. Okay, I don't know what was wrong with that naming. It's like my computer, like, in its brain for a moment. And if I looked at name, this would be the first element of name. This works for everything. So list can contain any type of information. And so I could make this a 1. I could make this a function. Let's say I had a function called user. I can make it a function out, and it'll still, hold on, I have to create a function, name. And actually, I wouldn't want to do it that way. Let's create another function. Let's call it cats. I know you hate cats. I don't care. I don't know what I do or don't like. Pass. Okay, there we go. So pass just means skip over. It doesn't have anything in it. So this is now a list. And so if I were to say pizza, and I were to call 012, it gives me 0. Oh, sorry. Numbers are out of order. I needed 3. Okay, 0, 1, 2, 3. It does nothing because there's nothing in there. But and it doesn't. I didn't call for the name of it, so this is it. I believe. I might be able to call the attribute. I don't remember. Yeah, it doesn't have attributes. Good. Okay. So they can be changed. So let's say I wanted to change cats to dogs. And I'm just going to copy and paste that and go to dogs. And we're going to do this. And if I just call this again, it says no. That's because it's called and it doesn't have anything there. I can do, let's do 3, and you can see something a little bit easier. Yeah, okay. I need to give it something. Yep. Okay. Not to print. Print goes to the bottom. There we go. And hopefully I'll wake up this morning and return. There we go. And that's all really convoluted. Okay. So I changed it from, so here I had cats. I gave it a string cats. If I were to have printed it up here, it would have printed out cats, but I created a function dogs and I called that function dogs and it called and put dogs as its output. So you can change the order. You can reverse this list. There's a lot of built-in functions. Again, you want to check your actual Python documentation, not the side sub coding websites. Those aren't really, they're useful, but like when you're learning, you want to orient yourself learning correctly in like the right direction of learning. And so to do that, you want to learn from the documentation and get used to and familiar with reading that and everything associated with it. So when we use it like this is called accessing by the index. These numbers, when I say position, it's called the index of where it is. And again, it's 0 through whatever number. And that's not true for all programming languages. So don't go switch between language or even packages and think that it's going to start at 0. Some of them will start at 1. And it's very confusing if you're using one that starts at 0 and one that starts at 1 in like the same code. It's frustrating because you have to match everything up, and it can be undoubtedly frustrating. Now, when we're talking about reversing list, this goes in the absolute opposite way. And so you would think, hey, this would be 0 still if you're reversing. No, it starts, we reverse from -1, -2, -3, -4, -5. So -5, -4, -3, -2, and -1. So if I wanted to call pizza -1, we've get onions. Yep. All the confusion, but it'll make sense after. Now, sometimes we need to get information from a list and it needs to be in a certain element. So let's say I only want elements 1 through 3, right? So let's do this, 1 through 3. So here we have 1 and we have cheese. Why isn't 3 included? Because this syntax, when you say 1, 2, 3, it means up to, but not including 3. If you want to include 3, you're going to have to do 4. Up to, but not including 4 is how I like to say it. Up to, but not including 4 is the best way to think about it. Now, we're going to look at some interesting things. So you can do, there's in the documentation, you'll find that you can skip. So this is up to, not including 4, and you can skip by like 2. So if it's a long list, you can go to every other, or every third, or every fourth. We'll have some of that practice. You can, let's talk about reversing list. So you can use the dot reverse, can't spell reverse, but instead of doing that, the short format, if you want to reverse a list, is going to be ::/1, -1. So now pepperoni is last. And that's the shortest syntax to reverse list. You're going to have to reverse list in almost all of those darn coding things. Some of the first ones are all about reversing lists. So what are we going to do next? We can check if a value is in the list. So we can check onions in pizza, not on pizza, in pizza. and it will turn true or it will turn false. So it's checking, hey, for any of the values in this list, is there one called onions? Is there not one called onions? And it returns true. You can have list within list. So let's say, let's go back up to my pizza. And I might have a cheese array. And this cheese array is going to have cheddar. Yeah. And mozzarella. And I'm a coding teacher, not a spelling teacher. So we're going to let that autocorrect. I'm pretty sure that's wrong, but you can spell it right in your code. But this is just a list within list, and what you'll see now is if I say pizza. Oh, I didn't run it. Let's run it. Pizza. Here. And the reason why this isn't dogs is because I didn't save it back to itself. So if I wanted this to be reversed and it saved back to itself, it would be like this. And then now this would be reversed. Okay. But since I didn't save it back to itself, it did stay the same. But here's a list within a list. So I can say 0, 1, 2, and that's going to give me this. Now, if I want cheddar out of it, I go to the element in that next array. So I wanted the second element of pizza and the first element in that second element. If I wanted mozzarella, it would be 1. And that's the cool thing about list and accessing list. Let's keep going. So we've changed them. We've kind of split them up. We can add elements. So we can add, there's a few ways to add. So let's see. So we have 0, 1, 2, 3, 4. I'm going to add element 5. And we're going to call it, what else goes on pizza? Vegetables. So if I do it this way, I get an error because there's no place already existing for 5. Remember, because it starts at 0, 1, 2, 3, 4. So that means there's no element for 5. So how do I get a 5th element on it? Well, we dot append. And so now, if I look at pizza, we have veggies. Yay! Now we can remove elements from it as well. There's nothing stopping us from removing, replacing. We can create a function, and we'll get into conditionals soon, and you'll be able to kind of iterate. It's called iteration, and change stuff there. But it's really useful. The other thing I want to talk about, which I forgot, I wanted to change some of my schedule. Let me see if I have it. Is how strings can be similar to lists, and how you might want to actually convert between a string and a list, because sometimes it's much easier to make changes if you treat your string like a list. So some ways that a string might be a list. So let's say we're going to call this Christina's Best Pizza, right? Okay, we have a string, Christina's Best Pizza Ever. So this is a string, right? So I can check, just like I can in a list, if there's the letter Q. Oh, yeah, can't forget those quotation marks. We're talking about string comparison. So it's Q is not in this string, but I can check for, we can see if C, will C be in the string? False. Why? Because it's very specific for capital and lowercase. So if I want to find that capital C, I'm going to need to change it to C. Now I can say, what is it, regardless of case, in just any case. There's regular expressions for that or a method. Again, we'll check the documentation when that becomes relevant. But we can do it like that. We can also check the length of this string, just like we can do a list. So if you have a coding problem, they're like, find the longest string. Okay, I got you. I'm just gonna put length. I'm gonna find the length. This is 24 characters. I'm gonna keep comparing until I get the longest one. String indexing works just like list as well. Let's copy that one down. So we're gonna call this R for restaurant. All right. And if I wanted to find R0, what do you think it will be? Yes, it's going to be my first initial. I wanted to find R20. It'll be E, this capital E here. R-1, it's going to be the last one ever. Now, you can still do interesting things. So if you wanted to find, if you were to like go beyond, try to find the 25th character, it will give you an error just like it would in lists. You can still slice this. So let's say 2, 2, 5. It's going to give you these pieces, right? I don't think in typical coding interviews these days you'll have to do too much regular expression, but if you're in like NLP or text mining and you need to find anywhere a set of patterns pops up, understanding how to look for the pattern is going to be important, and being able to split those out if necessary. Like medical records, I had to do that. It was so frustrating. But trying to find diagnostic codes or prescription short codes and where it is in the sentence and return it to a program are all things you can do. You can also convert this to a list. And I think that's by joining. So R dot join. I think I'm doing this wrong. Give me a second and look through my notes. You can do all of the operators, mostly that you can do at list as well with a string, just because of how it is. Here. Oh, I can just use list. Yeah, I'm so silly. So I can convert that to a list. And there we go. And I can save it to like RT. And if I, like I said, if I print it out, this is a list. And then you can kind of iterate over the list a little bit easier. Or especially if you have numbers, like a big number, you need to add 5 to every third, whatever shenanigans they want you to do. That's one way to do it. I used to have to use a join. But or maybe I'm thinking from list to, yeah, from list to, I can go the other way. You need a join. I think it'll be for, hold on, I'm gonna remember how to do this. Yeah, I think it's the other way. Join and RT. Yeah, okay. Other way around. What goes in, what goes out. So you do it on the space in the list that was created, and it joins everything together. Awesome. So what we're gonna do is I'm gonna put on some lovely music, and I want you to pull up the YouTube stats from 2023 data set in Kaggle, and you'll be able to go through and try some of the stuff out. And I will be in the forums if you need Any help? Alrighty, so we're going to move on to dictionaries. Dictionaries are just, actually, I don't think dictionaries are today. We're going to move on to, variables. We're going to move on to variables. Dictionaries tomorrow or later next session. We're going to move on to variables. So I've been saying for a while that we'll have a session on variables, and the reason why I kind of skipped over it at the beginning is it's a simple concept that I feel like when you see it in action, you understand what it does a little bit better. Like it's easier to extract what it does. So a variable is just a place to store information or a reference to that information, really. And we're not going to get into what I mean by we'll get into it, but there's a hard copy of the information and then there's like a reference to that information. This is important as you get higher up into coding, especially if you end up on the developer side or engineer side of the spectrum. For data scientists, I don't think it's as relevant to know the difference between the actual copy and the reference copy and like the pointer to. It gets confusing. And so it's not important. And maybe one day I'll have like an actual computer class with my like algorithms textbook. I think it's another one, but with my big old algorithms textbook, and we'll get into algorithms and data structures at that level. But this is not a computer science class. This is a learn a skill good enough to get a job class, hopefully. So here, variables are interesting, right? So here, I can have a one letter as a variable name. I can have a word. I can have a word and an underscore. There's different actually syntax for using underscores and things with variable names. But we can also assign at one time one variable to multiple different, like this, okay, to multiple different ones at a time. So if I were to call T, it's the same thing as if I were to call R, which is pretty cool. You can have different variable types, so they can be numbers, which have different variable types. They can be lists, dictionaries, strings, sets. Basically, anything can be stored in it, which is really cool. It can reference a full object. For example, if you look at like the apps, like if you're on like a YouTube, since we're using the YouTube data set, your profile could be a variable that is being passed in their code. Your profile ID or the object of your profile to show somewhere else, like the video content information. And so it can kind of store that information for use. And the variable is just assigning that reference. So multiple variables can have the same information stored somewhere. Variable names typically are going to be lowercase with an underscore. And actually it's best not to use, throwaway variables, fine, but for the most part, you want to make sure it's fully named out. So for the human who has to read and use your code again, it's understandable. We typically don't use camel case, I think, for variables. That gets very confusing. Camel case is like uppercase, lowercase, if it's human readable. So that's pretty simple enough. Now, we can do a few things. You're going to, just like you have in math, because I always say like computer programming, Python, whatever, it's called a language because there's grammar structure to it, right? So just like English, we have subject, verb, predicate, or subject, verb, agreement. Things you just use and you don't remember what it is. In other languages, it'll be the reverse, but in coding, you're going to have the order of operations you do stuff in, and you're just going to have to pick out what that is for what you're using and break it apart like that. So you're going to also have math associated with it. So especially in data science, and I want to do a whole class on like computational Python, which is how do you take, a research paper and like code out that algorithm they're talking about, or even think about it, or like they have that big equation and you're like, how am I supposed to use this for anything? And like, how do you get from a math equation to code that's usable? That's why you have packages like NumPy. You have stat model. And my brain just like, I can't remember the things, but that's why you have all of those. So you just want to learn how to do that. And that kind of helps you, like vector linear algebra type stuff, that helps you become like the data science that can't be without. Like you can do stuff that other data scientists can't do because you can actually code things into it. So your code is actually potentially not better, but what you can experiment with is going to be significantly different than someone who can only use pre-made packages. So you kind of want to do both. It also opens you to be able to contribute to packages. Like I found a package I want to contribute to because I want to use it. It deals with causal inference. And you'd be able to make your own package as well as work on other packages with people. So it's a skill set that you really want to know that makes you invaluable. You can get fellowships for for not nonprofits, but for open source. It is not for open source code. One good way is to get a fellowship with that open source code. It also shows skill. For example, if you don't have a job now, but you've been contributing to open source code and you can show that, or you can get a fellowship with that code platform, that really helps. Like if you're like Mozilla has like some open source components. Like if you want a job at Mozilla and you're contributing to the open source software, I mean, you're mostly more in the door than anyone else, especially if it's good contributions. Same with other businesses that have like open source technology and you're contributing to it. So it's really good to know how to do stuff outside of the packages. And this is the start. So when we're talking about operators, typically it's going to be math operators. It's going to be comparison operators. So like, is this true or is this false? Do these things equal each other so I can know what to do next in my code? Nothing complicated. You're going to have your less than or equal to. It's just like it appears in math. So I'm not going to go over it too much. I have the link should be in the description. And if not in the description, it's definitely in the resources in the classroom. So you can go over there. These things become much more important as you build code out, not so much important as you um, kind of learn. I feel like learning these outside of anything else is kind of hard. So what we'll do in order to get that practice in is we're going to learn all about if-else statements or conditional statements. We're going to pretty much focus on if-else and for. Those are the most common things used in Python. We have while. I don't really ever see it used. I have a feeling because of the infinite looping problem, it's just not, and I believe it's slow. Um, and yes, there are uses for it, but I'm just saying, typically in your job interview, I'm betting that it's going to be an if, else, or for statement that you're going to have to learn how to use in early in your career. It's just what it is. So we're going to learn about if, else, and logical statements, and then we're going to learn a bit about for loops, and then when we come back, which will be again a different link, we'll finish out with the runtime and just timing your code and getting practice in that. And then we'll stop for lunch and then we go on to dictionaries and sets. So let's look at if and else. So I like to think about if and else statements as if my mom was telling me to do something. And you're like, you're not a kid anymore, but my mom tells me to do things all the time. And so if if I do X, then I can do Y, right? Or if you come over and like help me pick these berries, my mom has a garden, then I can make like blueberry jam, right? Or I can get my blueberry jam until I go help pick, or my grape muscadine, my jam until I have to go pick. So if this, then that is what an if else statement then. And if this, then that doesn't work, what else can I do? I can go to the store and buy my own jam instead of getting homemade jam, or go to the farmer's market. Else go to the farmer's market and get homemade jam, right? There's a really great one back home who makes great jam. So let's look at it. So let's look at our, we're going to pull down, I think, from the space. Actually, I'm going to pull down home planet. I think I want to convert that into a list. So df, now we're going to go planet equals list of df home planet. Okay. So planet is going to be all of these, right? So I want to do something to this list. And I'm going to say if, I'm going to call it X. Usually going to use X, Y, Z, or S, a TU and or ST when you're just making random stuff, right? So if X is equals, I'm going to say Europa. See, I can't spell it. I'm looking at the word. Okay. Then what do I want to do? I want to say, I'm going to print, yeah, okay. And this is the sign that I'm in equals. Else, print, nope. And so we are going to actually substitute this because this is a list. Haven't taught you how to iterate. So we're going to pull out the first item in this list. And that first item is going to be planet. And this is why we have loops. We'll get to that point. We're going to do this painful way first. So this, does it equal Europa? Yes. Does the next one equal Europa? Nope. What about the one after that? Yep. And the one after that, we're going to say, yep. So we're like, huh, how do I know it's right? Well, this is where we're going to pull some fancy F strings. Again, this is why we don't do this way. We're going to put planet. I'm going to have to put this in. This is why we loop and we reuse the variable. It's going to be very frustrating, but you'll see why in a minute. Okay. All right, so now, because I don't have a variable here that is looping through and filling in this for me, I'm going to have to change all of these to 1. Earth is not Europa, so no. And that's kind of what if else is checking. It's checking a condition. So if something's present, you can check if in. So what we can do, if I do if in, so we're going to say Mars, if Mars in planet. So Mars is in the planet. What about Jupiter? No, there's no Jupiter. And actually, it's going to still print it 1, right? And so we can check. We can do, let me see if this is pandas or if this is Python. Yeah, it's pandas, so I can't do that. So we can check the documentation. This is a good example. And actually, I might be able to do count, but I doubt it. I think I have to iterate myself like a counter. Yeah, it won't do it right. Okay, so what will we do? Actually, you know what? I don't need the documentation. I'm silly. We can actually do a set. We'll talk about set in the next one. But if I want to define all unique, we'll set up all of them. So these are all the ones in that thing. Okay, we'll get to sets next time. I'm just like, Saturday morning. These are, and again, notice that I'm indenting in Python. Everything is by indentation. So this here always needs to evaluate to true or it evaluates to false. Usually else or else if is going to be your false. So if this is true, do this. If this is not true, do this. And else if something else, then do this, right? So think about it in terms of true or false possibilities. is what you're looking at in your if-else statement. And you can basically do it like that. Let me show you what else if. And if means I have to give another condition. So we want to say Mars. We're going to print okay. So this kind of check. Oh. Okay. So Mars is there. And so since this was the true statement, it took that one, even though there was options for the other ones. Oh, my brain teaching on the fly. So we can do these in one-liners. I don't like it because I don't think it brings clarity. Like you can put this in one line. I just don't find that easy to read or scan, so I don't do that. Let's talk about for loops so we can get to list comprehension. So there are several different ways to do for loops in Python. I'm going to teach the most Pythonic way to do for loops, like how would people who work in Python for years do it. If you've taken Python before, have probably seen like range in lambdas, a bunch of stuff, but we're not going to do those. We're going to do it in the way that I find people who work in Python do, the most Pythonic way, and that's with enumerate. So we have a planet, right? And so we are going to basically use the enumerate method. And the reason why they do this is because it'll tell you kind of where it is and then what's there all in one line, so you don't have to actually write the index. And so for count, and this is the value, and enumerate, and then you put the value you're looking for here, right? And then you can print count value. So now you have like the actual index and the value for whatever you need to do. So this is the index is 0, the value is 1. I mean, the value is the Europa. And so here you can basically, you have, this doesn't have to say count. This could say X, Y. But if you say X, Y there, then you're just going to say X, Y here. Yeah, X, Y here. It's the same thing. But then you could do something on it. So you could say, you can just say Y. Well, that's fine. It won't put the index there, but you can also just have an F. And now for each one, it'll print out a whole sentence. Their home planet is, and you'll have Y. You want to make sure you close that up. And so there, we have whole sentences now, which is really kind of cool. Now, if there was numbers, so let's go up. we have this whole, I don't want to use age, I used age yesterday, made them all 5 years older, you know. Let's look at the food court. They should definitely have pizza in here, and if they don't, I'm going to be very sad. So let's do this. So for X, Y, N, we're going to create food court as a list. So we're going to call it FC for short. And we're going to say create list from data frame column food court. See, that's how you say code out loud to see if it makes sense. And then we're going to have FC. And then now what I'm going to do is I can actually print out times 5. Hold on, let's print out this first. Oh, yeah, silly me. All right, now that needs to go on the inside. There we go. So, and let's do, I'm only going to do the first 5 there so we can see it better. And I'm going to print out it without the 5 so we can see that it did change. So this is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4. Let's print out X, Y. Because it's running both. So this is 1, 0 times 0. Yeah, 9 times 5. Okay, so this is both back to back. So that's why we also need the index. And we'll put a comma here, put a comma there. There we go. These are all paired together now. So for the first index, the initial was 9, and times 5 would be 45. And now you're really coding because you're doing some stuff. You're manipulating the data and the information, which is kind of what you really want to be doing. I like enumerate. I like iter rows, iter items. We'll talk about iter tools and collections. Actually, yeah, we'll have time. Iter tools and collections. So now that we have kind of this, what I'm going to do next is going to be, we're going to put this inside of a function. So all I typically do, even when I'm doing is work, I kind of just write things in a function, tab this over, and then I can call court. And actually, let me and see it runs in that function. I can pass values to it if I wanted to. I don't at the moment. But that's all you do. I wrapped it in a function, print it. I can still return it. It doesn't matter whichever one I want to do. I can let's say I wanted to actually call it. So this would be calling Z. Z comes from there. So that means I'd have to put something here. I just go like this. Press the same thing. And actually, let's change that so you can see that it's not just in memory. All right. So let's talk about, I guess, the next step after something like this. You have this enumerate and you have 4, but is that the most Pythonic way to do it? No, because we can actually create what's called, well, not in this case, yeah, but we can create a list comprehension and it increases the processing speed as you're kind of iterating over because it's going to automatically save it back to that variable in list format for you instead of you having to, you used to have to hoist everything into the list and that was complicated. So here I want to say, because you know we're thieving them and we're increasing their bill times 5, they're going to be mad at us. And we're like, we're dominating. Yeah, it's fiction, not real life. Okay, so we're going to say increase bill. That's what we're going to call it. All right, we're going to call a list. Now, next what we're going to do is we're going to copy this 4, paste here. And what then we're going to do, we're going to copy this increase fill. I'm going to copy the whole print string. That's what I'm going to do. I know we're not going to print. Actually, all that can go. Okay. And here we'd have this. So what is a list comprehension? Basically, you run all your loops inside of your brackets. This is going to be the same for these brackets when they're brackets for loops. When they're curly brackets, we'll talk about dictionaries, they'll look like that. You have generator functions as well, which are generators. I don't think they're sets. They might be. But we'll talk about that. And it's basically just going to save it automatically for you into a list. So if I do ink bill, you're going to notice that all of that was here is already here for you, and it runs really, really fast. All right. This is very useful because also, let's say I have 2 lists, and so we can do for an if. Actually, this is going to be better. I think it's in an actual table, so I don't know if this will work. But if Mars, yeah, it's going to be better if it's actual table. But essentially, let's say I wanted everyone on planet Mars because to have increased bill by 5 and everyone on planet Earth to have a reduced bill by 5. I can basically put a if this, then it'll run all of this, right? You can do if else in there too. I think that gets a little big and a little confusing. But for simple if statements, you can just say if planet equals Mars. And that's good if you have, like, you're actually dealing with pandas data frames. You have a table. And you can basically query on one table and the other. But I don't want to teach you pandas today. But we can do something like if y is less than 15. Well, yeah. So let's do that. So 0 get multiplied by 5. We can do if y is greater than 15. So it's going to multiply the other 2. But you can basically caveat what you want to happen and to whom you want it to happen to. Actually, you know what? I just realized I'm in the wrong live. No, I'm not. I'm in the right live. I changed lives next. Tired. Okay. So let's talk about, those were list comprehensions. Those were for loops in the Pythonic way. Am I missing anything? You can create an outside function as well. So you can pass a function here. So let's say I wanted to do it like this, right? So we're going to copy, we're going to paste, and we're just going to say if y greater than 15, we put in there y times 5 else y plus 15. All right, and so now I can do df. I'm not going to do core, sorry. I'm not defining a function. And we can pass y here. And it should be z, sorry. Whatever I pass in, everything has to be named accordingly. All right, and so let's just do from 0 to 9. sure this is wrong. Yeah. So what went wrong? If C is greater than. So for this one, shouldn't be none. I defined court. Z equals return Z. Yep, don't forget your return statement. It had nothing to come back to me. So now if I there we go. So zeros became 50, 9 is less than 15, made 59. This they multiply times 5, times 5, times 5, times 5, times 5, 50, times 5. Yeah, never forget your return statement. It basically was like, we did it, but it didn't tell us anything to give back, so it didn't give us anything back. So cool. What else was on the agenda? All right, I think we're going to, the session finishes up at 11. I'm going to give you guys some time to play with the YouTube stats data set that we talked about in video 1. That's on Kaggle. And I want you to play with the numbers and play with the strings using functions and list comprehensions. I'm going to put on music for the first probably 20-ish minutes. I'll be in the forums answering questions in the class forum. And I'll turn off the music after 20 minutes and let you guys finish up. We'll come back here at 11:10 to continue with runtime. Like how do you time your functions, and we'll go from there.